Hello class, this is a video for section 2.6, and in this video we'll talk about the limits at infinity, which is also same as finding the horizontal asymptotes. Okay, these are our learning objectives. The first will determine the horizontal asymptote or limits at infinity, and then also the vertical asymptote, which is also called the infinite limits that we'll discuss in section 2.2. Okay, of a function. So as you can see, if I want to graph a rational function, right, we have to find the domain, we have to find the x and y intercepts, and we have to find the horizontal and then the vertical asymptotes, right? And then we pick values and plot the points and go to sketching. So in algebra 126, that's what we used to do. Now here we are finding the same things, especially, the asymptotes using what? Calculus, which is using limits. So it will get to a point that we'll be able to sketch the graph, okay? When we are able to get all the things that we need to sketch a graph, okay? So remember that. And then in this also, we'll look at the infinite limits at infinity. What that means is that when you find a infinity, the x is getting larger and larger to positive infinity or negative infinity, the answer is negative or infinity or positive infinity. Okay. Now there's a third one, but we're going to skip that. Now let's consider this example. Say that let x become arbitrarily large. All right. That it could be positive or negative. Arbitrarily large means that it's increasing arbitrarily to positive infinity or negative for infinity. So we want to begin to investigate how this function behaves around that. Okay, as x becomes large. And again, when x becomes large, we're going to consider peak values that increases negatively or positively. So let's go to the next slide. We have a table, okay? So in this table, what we are doing is that I'm picking values from 0, okay, x from 0, and I'm increasing it to the right, and then increase it to the left, and find the function value, which is the function is f of x is called x squared minus 1 over x squared plus 1. So don't forget, this is the function. And so if x is 0, right, this function is you have negative 1 over 1. That is why I have negative 1. So if x is plus or minus, it is still 0. Now, if it is as you increase in, look at it, when x is 10 or negative plus or minus 10, 50, plus or minus 50, plus or minus 100, plus or minus 1,000, we can increase it to plus or minus 10,000. Now look at the value, okay? Look at these values. You see that is approaching a positive 1. It's approaching a positive 1. So we can say that the limit as x goes to positive infinity is equal to 1. And then also x goes to negative infinity is also equal to 1. Okay, so this is what we mean by limit at infinity. Now this is a graph of the function, this rational function. Now you see that as we increase the x to the right, it's approaching a certain value, okay? And then to the left also is approaching a certain value. And that value is 1. So you could see that the line, okay, y equal to 1 is a horizontal asymptote, HA. So that is where we are going. All right. Now, generally we will say that this is a notation, okay? If you have the limit, to take the limit x approaches positive infinity of a function is equal to a certain value, it exists. Or the other definition is that when you consider x approaches negative infinity of the same function and is equal to, let's say, L, all right? Or it could be a different value, or maybe a D. Then you can say that the line, for the first one here, the line y is equal to L is a horizontal asymptote. Or you can say that the line, for the second case, if you have this, that the limit x approaches negative infinity of the same function f of x is equal to d, then we can say that y equal to d is what? Horizontal asymptote. So that is basically the definition of horizontal asymptote and using the limits to find that. Okay, so intuitively, that's what I'm saying right here. Okay, now if we go to when you look at x approaches what? Negative infinity, right? If you get the same thing. Now, one thing you should note is that, okay, when f is what? Defined on some interval from a to positive infinity. So you are increasing x to the right, that's a, and we are going to the right toward very large, okay? And you get this, and then also the interval is what? From negative infinity to a. So here you have a, and you are decreasing this what? To the left, okay? So then we can say the line y equal to what? L is what? A horizontal asymptote. So formally, we say that the line, as we just kind of summarizing that, is called a horizontal asymptote of the curve y is equal to f of x. If either or, it doesn't have to both of them. You just have to do either positive, x approaches positive infinity or negative infinity. Either or should be what? To help us to find the what? The horizontal asymptote of the what? Of the function. Okay. So as in this example, we want to find the limit x goes to infinity of the function f of x. So here, your f of x is 1 over x. Now, as you can see, if x is what? Getting larger and larger, this is getting smaller and smaller and approaching what? 0. So if I take x is 100, okay, the function value, that is what? X over x is what? Is that? If it is x is 10,000, it is what? 0.0001. 1 million is what? 0.000001. So it gets smaller and smaller. In fact, if you look at the graph, what we are saying is that as x is increasing to the right, this is what? This is approaching what? It's getting closer and closer to 0. And then when you're going this way too, it's the same thing. So that is why the x-axis, x is equal to 0, is what? Is a horizontal or asymptote for this function. Okay. Now, generally, we can also have a graph for what? X squared. In fact, this even approaches what? 0 faster, okay, than what? 1 over x. And so if you generalize it, okay, or summarize what we just said, then if this goes towards 0 and the negative also go to 0, then we can say that the line x equal to what? Y equal to 0. Let's say y equal to 0, not x equal to 0. Okay, it's a horizontal asymptote. Now, that's the same as saying that what the x-axis, okay, it's a horizontal asymptote. Okay, I think I misspoke in the previous slide. Okay, so it's not x equals 0 by y equals 0 or the x-axis. Okay, so if r is positive, then if you have something like what? 1 over x, say 3, all right, when you have for f of x is equal to that. Now, what is the limit? X goes to what? Either positive or negative infinity. It's right here. The limit x goes to positive or minus infinity of 1 over x squared. That will approach what? 0, get smaller and faster. Okay. Okay, that goes to 0. So it's an extension. This theorem is an extension of what the previous one theorem or the definition. All right. Now, the example that we just solved, okay, remember we use a table, we use a Gauss method. Now I want to do the same thing algebraically so that I don't have to always use the Gauss method to find limit. Now, as if you can remember, we start with the what? Using limits, using the table or guess method to find the limit of a function. And then we also use algebra, okay? And so that is what has been going on. And then we can also use the laws. I mean, in addition to what? Algebra. So if I want to find this, just like you did in algebra, in Math 126, right? If you want to find, say, the horizontal asymptote of this function, you look at the coefficient, they have the degrees. This is the degree is 2, the degree of the denominator is 2. So in that case, the coefficient has to be the ratio of what? The coefficient. So which is 1 over 1, which is what? 1. And that is the line y equal to 1 is what? A horizontal what? Asymptote. So this is using what? Algebra. Okay, but we pass algebra, we are using what? Calculus as limits. Okay, this is how we approach it. Now, if I want to find the limit, x approaches negative infinity, the limit x approaches negative infinity of the function x squared minus 1 over x squared plus 1. Now, what we do is that we're going to divide. I think I made a statement there. Okay, we'll divide. Okay, we'll divide by the x with the highest what? Exponent in the denominator. In the denominator, okay? So, which is what? X squared. So what we're going to do is that this will be the limit x approaches negative infinity of what? X squared over x squared minus 1 over x squared. Now, note that it is what? This denominator x squared that I'm dividing the top and bottom by, okay? So I have x squared over x squared minus 1. This is plus over what? X squared. So this gives us the limit x approaches what? Negative infinity. So this gives me 1 or minus 1 over what? X squared. Then 1 plus 1 over what? X squared. Now this limit is what? Is the same as the limit x approaches negative infinity of what? 1 minus 1 over what? X squared divided by the limit x approaches negative infinity of 1 plus 1 over what? X squared. Okay. Now you notice that the numerator there will be 1 minus the limit x goes to negative infinity of 1 over x squared divided by 1, because the limit of a constant is constant, then plus the limit x goes to negative infinity of 1 over what? X squared. Now this goes to 0. Okay, this part goes to 0. This part also goes to 0. So the answer is what? 1 over 1, which is equal to. So that would be the answer. Okay. So I've used algebra or limits to find the same word, horizontal asymptote, when we could have used what? Algebra from Math 126. Okay. Now here's another example. We're going to consider this the same way. All right. Now let me mention something. The limit x goes to negative infinity. Okay. This is approaching 0, and you don't have negative 0. So this part will go to 0. All right. That also will approach what? Even go to 0 faster than what? 1 over x, as I mentioned before. Okay. So we're going to approach this the same way. Oh, so then we didn't finish. It said state the horizontal asymptote. So the horizontal asymptote is what? The line y is equal to what? Okay. So here we do the same thing. We have the limit goes to infinity. Then because we look at the x squared here, we divide the bottom and numerator and denominator by what? X squared. So we have 3x squared over what? X squared minus x over x squared minus 2 over x squared, then divided by 5x squared over what? X squared plus 4x over what? X squared, then plus 1 over what? X squared. Now this will simplify into x goes to positive infinity. You get 3 minus 1 over x minus 2 over x squared divided by 5 plus 4 over x and then plus what? 1 over what? X squared. Now let me pick a different color. Now what will happen is that if your x goes to infinity, this goes to what? 0. That goes to even 0 faster. This term goes to 0. That also goes to 0. And so your answer becomes, okay, the answer is what? 3 minus 0 plus 0. Oh, sorry, that's minus. And you have what? 5 plus 0 plus what? 0. So the answer is what? 3 over what? Over 5. Therefore, the horizontal asymptote is the line y is equal to 3/5. This is the line. That's my horizontal asymptote. Okay. All right. So in this problem, we want to do both horizontal and then vertical what asymptote. All right. Since we did that we found the horizontal asymptote, that is infinite what limits, where horizontal asymptote is the limit at what? Infinity. So we know the difference. Horizontal asymptote is what? Limits at infinity. Vertical asymptote is what? Infinite limits. Okay. So here we're going to treat this just like what with it. So first we want to look at a vertical horizontal asymptote. All right. So that's why I said that, okay, we're going to divide both numerator and denominator by x in the what? Over here, not the top. X in the denominator. Okay. So you have this. Let's do the limits. I can do x goes to either positive infinity or negative infinity, okay, of what? G of x, which is the limit. X goes to negative infinity of 5 over x plus 4x over x divided by x over x plus 3 over x. So this is going to be the limit. X goes to negative infinity. This is 5 over x plus what? 4 divided by 1 plus what? 3 over x. So like we said, if you have the function of this form and x is getting bigger and bigger, it goes towards 0. So that goes towards 0. This also goes to 0. So if x approaches negative infinity, then we have what? 4 over 1, which is what? 4. So it means that the horizontal asymptote, okay, is what? The line y equal to 4. And then what is the vertical asymptote? All right. What's the vertical asymptote? Now consider the denominator, which is what? X plus what? 3. We don't want this to be what? We don't want to be 0. So if x is equal to 3, then the negative 3, sorry, then the denominator is what? Is 0. And so that's why we have to find the limit. All right. So we're going to be the limit. X is approaching negative 3. Okay, negative 3 of what? 5 plus 4x, okay, over x plus what? X plus 3. So I can just consider approaching this from the right or from the left. Since we don't want it to be exactly 0, approach it from the right or from the left. Okay. So if I'm approaching this -3 from the left, remember, see that is a number line. Here is -3. So I have values coming this way. So I'm going to just pick a value which is very close to that. So I pick what? To 3. Let's say I pick -2.999 and substitute it, because I could use the table to do that. So please note that this one, don't divide by what? X. I don't treat it like I did it for horizontal, because it is not a limit at infinity. Okay, so then this becomes 5 plus 4 times minus 2.999 divided by negative 2.999 plus what? 3. Okay, so this will definitely give me 5 minus 11.996, okay, then divided by, that is going to be 0.001. Now, if we do simplify this, I'm looking for the sign, not the what? The actual value. I know the numerator is what? Negative. The denominator is what? Positive. So this will go to what? It's going to be undefined, because if I'm dividing by this, it's going to be a big value. So it will be what? Negative what? Infinity. And therefore the line x is equal to what? -3 is what? A vertical what? Asymptote. Okay. All right. Now, the final thing is I want to look at the infinite limits at infinity. That means sometimes as you increase the x arbitrarily to the right infinitely, or to the left infinitely, the value gets bigger and bigger and bigger. Okay, so we have certain functions that we're going to talk about in a minute. All right, so here's a notation that what this means: the function, the infinite limits, okay, the infinite limit at what? Infinity. That's what it means. That if I take a function, f of x, and approach the x going positively large, I get a large value. Okay, or if I take it could be that if I take x approaches what? -infinity, I get positive, or positive infinity, it goes to negative, or it could be what? From negative, as x approaches -infinity, I get what? Negative, or gets bigger and bigger. Okay, we'll look at some of specific what? Examples. Okay, let's look at x of x squared, sorry, x cubed. Now you notice that if x approaches positive infinity, all right, so let's say x is 10, x cubed is what? 1,000, x is 100, it's what? 1,000,000, x is what? 1,000. If you cube it, you get what? 1,000,000,000. Right. So what is happening is this, that if x is approaches what? Positive infinity, right? That x is going to what? Positive infinity of x cubed. This is what? Getting bigger and bigger, positive. Okay. Now, similarly, if you consider other values, if x is -10, okay, if x is -10, if you cube this, you get -4, -1,000. If you have -10, -100, if you cube that, you get -4, 1,000,000. Okay? Like that. So what is happening? It's going to go to negative. So similarly, if you have the limit as x goes to -infinity of x cubed, you get what? -infinity. All right. So that tells me that this is goes to infinity. Then it doesn't become an horizontal asymptote, but it gets bigger and either to the right or to the left. Okay. So what we talked about, I just explained this here. All right. is there. Now this is the graph of x cube. Now you see that as x is getting larger and larger, this is getting bigger and bigger, y values. If it is getting larger and larger negatively, all right, this is also getting larger and larger. Another example is what? The exponential function. Okay, exponential. It gives us two, okay, I call this exponential function. So you have y is equal to e to the x. What is the graph? The graph is like that. Okay, so the limit, this is y is equal to e to the x. The limit, this is x. As x approaches positive infinity of e to the x, this is, guess what? This gets bigger and bigger. Okay, but the limit x approaches negative infinity of e to the x, this goes to what? This goes towards 0, because it gets smaller and smaller. As you go this way, it gets smaller and smaller to approach towards 0. Okay, so in this case, we can say that the line y is equal to 0 is what? It's a horizontal asymptote, but here, this is what we're just talking about. That is the what? Infinite limit at what? Infinity. Okay. All right, now, this is the last example. We're given certain conditions. We want to sketch the graph using the limits that we have talked about. Okay, so I'm going to, this is my graph. Okay, you want to know what each of these mean. This is my y, that is my x. Now f of 0 is 3. What does it mean? Okay, this is what? 1, 2, and 3. So x of 0 is f is 0. This is what? That's the point. Okay, it exists. So it is what? It's a hole, is what is closed. Now, when you say that x approaches what? It's 0 from the left and is equal to 4. What does it tell me? Okay, x is approaching 0 and is equal to 4. Well, if you are going this way, this is what? 4. There's a hole there. Okay, all right. And then this one to the right, it said it is 2. If this is 1, this is 2. There's also a hole here. So what is happening is that we'll figure out what is happening, whether the graph is going up or coming down. In that way, we'll figure out. Okay, just a minute. Now let's continue. When I have, this is f of x, not 9. As x approaches negative infinity, right? X approaches what? Negative infinity. F of x goes to what? Negative infinity. Okay, so what this means is that this is telling me that as x is going this way, y is actually going that way. It's getting smaller and smaller. So it means that if I'm coming this is what? This graph is actually what? Coming down like that. It's going this way. So as x is getting larger negatively, the y is value is what? Getting larger negative. So that's how it goes that way. It doesn't become like that. Okay. Now, on the other hand, when you say that x approaches what? 4 from the right, this is, let's say 1, and then 2, 3, 4. This is 4. It says x approaches what? 4 from the left. You go to negative infinity. Okay. What does it mean? It means that this line, the line x is equal to negative 4 is, sorry, positive 4. X equal to what? 4 is what? It's a vertical what? Asymptote. And so we're going to have what? A vertical asymptote here. Okay, this is 4. Okay, as x goes to what? As x approaches 4 from the left, the graph goes down like that. And then as x, this part, x approaches what? 4 from the right, it goes to positive infinity. It goes up like this. Okay, and then it says that as x goes to positive infinity, it is increasing. This goes to what? 3. So it means that the line y is equal to 3 is what? A horizontal what asymptote. And so this line, this is 3. That's a horizontal asymptote. Okay, this is the y is equal to what? 3. And so this graph is going to behave like that. Okay, and then goes up. And then between here, this is coming down like this. And so we get the graph for the function f of x. This is an example. It could be different, but this is how we get the answer. I hope this is helpful, and we'll do more examples in class. I'll see you soon.